Welcome to Chemistry with Dr. Z. I'm Dr. Z, and in this video, we are going to talk about Group 7 elements. This is part of the specification for both GCSE and IGCSE. So group 7 elements are the halogens, which are found in group 7, which you can in the periodic table, it's on the right hand side next to the group 0 element. So this is group 7 elements. The most important members of these groups or the elements that you need to know very well are fluorine F, chlorine Cl, bromine Br, and iodine I. So group 7 elements are called halogens and they exist as diatomic molecules, unlike the noble gases where we said that they exist as monoatomic elements. The halogens exist as diatomic molecule. This is why when we write them, we write them as a diatomic molecule. So fluorine is F2 and chlorine is Cl2, bromine is Br2, and then finally iodine is I2. That means that each molecule um, um, is formed of two atoms. They are nonmetals because they exist and we can find them on the right hand side of the periodic table, and they all have colored vapors. So because they are group 7, we know that the group number refers to or reflects the number of electrons in the outer shell of the element. So group 7 elements all have 7 electrons in their outer shell. In order to reach the stable configuration of a full outer shell, they tend to gain one electron to form a negatively charged ions with one negative charge. So with metals, they will form what we call ionic bonding or ionic compounds. Because metals tend to lose electrons to form positively charged ions, and halogens or group 7 elements tend to gain electron to form negatively charged ion. So the oppositely charged ions will interact with each other, with each other, and they will form ionic bonding. With nonmetals, they do not gain or lose electrons, but they tend to share the electrons with the other non-metal, and they form a bond called covalent bonding. Some examples of covalent compounds with the halogens is hydrogen chloride. So just to know the physical properties of the halogens, so fluorine is a very reactive halogen, and it's a poisonous yellow gas. Chlorine is fairly reactive, so it's a bit less reactive than fluorine. It's poisonous and it's dense green gas. Bromine is dense, poisonous, red-brown, volatile liquid. As you can see, we moved from gases into liquids now. And finally, iodine is a dark gray crystalline solid with purple vapors. So all of the halogens have the colored vapors. So what about the trend of the reactivity for the group 7? Um, Group 7, unlike the group 1 elements, as you go down the group, the reactivity will decrease. So we saw in group 1 elements, the alkali metals, as you go down the group, the reactivity increases. Group 7 elements, as you go down the group, the reactivity decreases. The reason behind that is because if you go down the group, it will become harder to gain an electron because the outer shell will be further away from the nucleus. Group 1 elements, the outer shell will be further away from the nucleus, so it's easier to lose electron. This is why they become more reactive. Group 7 elements, however, they gain electron. So as the outer shell becomes further away from the nucleus, then it becomes harder to gain an electron. When we look at the physical properties like melting and boiling point, we can see that all groups have the same trend. The boiling and melting points will increase down the group because there will be more electrons as we go down the group, and more electrons means more intermolecular forces. So more energy is needed to break the intermolecular forces between the different atoms or between the different elements. Then as expected, as you go down the group, there will be higher relative atomic mass. So let's have a look at the chemical reactions for the halogens. The first one is that halogens react with metals to give ionic compound. So let's have a look at the example in front of us where sodium reacts with chlorine to give sodium chloride. So halogens, when they gain electrons, they form ions called halide. So chlorine becomes chloride. So the ion is called chloride and the element itself is called chlorine. Same way, bromine becomes bromide when you talk about the ion. So sodium is a metal and it tends to lose the electron it has in its outer shell, and then as it loses this electron, the chlorine will gain that electron. So now chlorine will have the extra electron in its outer shell. It will form the chloride ion, which is negatively charged ion, so it's -1. And sodium lost one electron, so it formed a positively charged ion, so it's +1. Then the negatively or the oppositely charged ions will have an electrostatic interaction in between them to form what is called the ionic bond. With nonmetals, this is the second reaction. With nonmetals, they will form covalent compounds. So covalent compounds are these compounds which have a type of bond called covalent bond. Covalent bonds comes from the sharing of electrons between elements rather than losing and gaining electrons. So there is no positive and negative charged ions, but the two elements will share the electrons, and the shared electrons will still give the atom the stable configuration of the full outer shell of electrons. So when we have hydrogen and chlorine and when they react together, the hydrogen has only one electron in its outer shell. Chlorine has 7 electrons. So chlorine shares one electron from its side and hydrogen one electron from its side. And this pair of electrons from both atoms will form this bond, which is the covalent bond. Now chlorine with the shared electron from the hydrogen will have 8 electrons in its outer shell. Hydrogen, because it has only one shell, or which is the first shell. Now hydrogen has a full outer shell as well, which will have 2 electrons. So this is called covalent bond, and this compound is called a covalent compound. A third type of reaction for the halogens is the displacement reaction. So the more reactive halogens will displace the less reactive halogens from their salts. What do we mean by this? That means if you have a halogen like chlorine and you reacted with a salt of a less reactive halogen like bromine, as reactivity decreases down the group, so then the chlorine will displace the bromine from its salt. So when you react something like chlorine with potassium bromide, this is the salt of bromine, then it will form a salt of chloride. So the chlorine will displace the bromide. So it becomes potassium chloride now, and then bromine will be formed as well. So now the halogen, the more reactive halogen, displaced the less reactive one from its salt. You can do the same as long as the halogen that you start the reaction with is the more reactive one. So chlorine can do the same with, let's say, sodium iodide, for example. So if you react chlorine with sodium iodide, you're still going to get sodium chloride plus iodine. But iodine cannot displace chlorine from its salts or bromine from its salts, because iodine is less reactive than chlorine and bromine. So you just need to look at the periodic table and decide which halogen is more reactive, which one is less reactive. We know the activity tends to decrease down the group, and then you can decide which one can displace the other in its salt.